Well, here's a little video that hopefully you'll find interesting. It's to show you from the start to the finish, right the way through, how to operate a 2-inch scale Fowler A7 traction engine. So the very first thing with any steam engine is to make sure that there's water in the boiler. This little plug at the base of the valve chest and cylinder block here removes quite easily, and you can pop in a rubber hose with a funnel on the top to get some gravity fed water to siphon into there. It's important to open any valves on the boiler to let some of the air that might be trapped in the boiler out, which will let the water flow in much faster. And if you look at the gauge glass now on the back head of the engine, you can see that the red stripes change direction where there's water in the glass. So it's really easy to see how much water you've got in there. At the moment, about a quarter of a glass. Moving to the bunker now, there's an extra supply of water under the floor on the footplate, which is accessed by the little filler cap on the side there. This is just cold water, and it's the extra water that you carry around with you to replenish that's been boiled off as steam. Should fill the gauge glass up to about halfway on the boiler, because as you heat it up it will expand, as we'll see later, in the gauge glass, and you'll have more water in the boiler than you started with. Now this is Finn lining the firebox inside there with paraffin soaked charcoal. Charcoal's really good to get started, and the paraffin soaking of it allows it to light much easier. So once he's got a good bed of flammable material in there, you'll see him in a second light a piece which he'll pop in on top, and the whole thing will catch fire dead straight forward. Now there's not a lot of air inside such a small firebox like that, and you'll see that the flame doesn't appear to burn very well straight away. So Finn's going around the front to connect the battery up, which is connected to an electric fan blower, which we've got perched on the top of the chimney. Now that literally sucks air right through the chimney, through the tubes and through the grate into the fire, and allows the fire to really take hold and burn like you can see here. Oiling up here, you'll notice that we actually oiled up before we put the blower on so that it'd be quieter in the background for the voiceover. This is all the cold parts at the top of the engine that aren't surrounded by live steam pressure, and essentially it's a slideway oil, a relatively thin oil that just gets around all the parts that might rub and move onto each other. There's certain oil pots, some have lids, some don't, and then there's also, like Finn's about to do here, along the top of the crosshead and then on the slide bars at the bottom. Just anywhere where there's a moving surface where friction could occur, you want to get a surface of oil between the two just to allow it to move properly. This is the expansion link and the die block inside there, which is to allow it to be put into forward or reverse. We'll cover that a little bit later on. But again, there's little dimples in the top which go through tiny little holes to the actual axle surfaces in between and allow it to be oiled. Inside these ones that you can see Finn just oiling there, there's little wicks inside the oil boxes on the top. This is for the main crankshaft, and there's little wicks that allow the oil to be slowly sucked up and fed into the brasses and the bearing surfaces. Moving on to the footplate, there's a little oil pot for the water pump. We'll cover that in a little more detail later on. And then there's two more little oil pots for the shaft that holds the gears across, which if you look underneath the tool tray you should just be able to see that. And below it there's the main axle as well, which has two more pots hidden away. Easy to miss those. Then onto the steam oil. This is a thicker oil used in the cylinder and the valve chest in a mechanical lubricator up the top here. Now obviously there's a pressure, 90 psi in this case, and hot steam going through the cylinder and the valve all the time, and therefore it's constantly effectively being steam cleaned. So you need a little pump, which is what's in here, and if you see me turning the ratchet round you can see the little pump ram going up and down and pumping that thicker oil, designed for a hotter use, in through the cylinder with every turn of the flywheel, which John will show you now. So back to the fire, we're on to coal now, and it's small anthracite beans in there, which is a high temperature, hot burning smokeless coal. And you can see now that we're up to pressure, Finn's taken the electric blower off and he's opening the steam blower around the front of the cylinder, which is a little jet of steam that blows up the chimney, and it causes a draft to go up the chimney and a vacuum in the front smoke box, the black part on a steam engine, and just pulls the fire through, drags the air through the fire and through the tubes and up the chimney. The pressure, as you can see, is about 50 psi at the moment, which is just about the right pressure to change over. And you can see here that the water has expanded right the way up the gauge glass. We've now got 3/4 of a glass. This is a good opportunity to test the injector. Here's the water valve, which allows water to flow from the water bunker in the tender down through the injector, and then the steam valve, passing into the injector, works through a complicated series of Venturis to Bernoulli's principle of fluid dynamics, if you want to be really technical. If not, it's black magic and voodoo. But essentially, it injects water into the boiler using steam pressure against that steam pressure. Super clever, but really, really useful. With the engine now ticking over in reverse, it's a good opportunity to look at the valve gear. There's eccentric discs attached to each eccentric rod, and when the eccentric rod is in line with the valve rod, that eccentric rod and that eccentric is in play and opening the valve and shutting the valve at the correct times to allow the steam into the front and the rear of the cylinder for that direction. If we then stop the flywheel and pop it into forward, you'll see the other one drops down and becomes in line with the valve rod, which is set at a different position. The eccentric's set in the opposite position, and therefore it moves the valve rod in exactly the opposite way, allowing the steam to go in at the other end of the cylinder, and thus the flywheel turns the opposite direction. Moving on to the safety valve, there's one spring centrally in the brass cylinder and two little cups that are mounted in the top of the valve chest, and the lever balances the force between the two. They're working fine. The gears on this engine are a little bit difficult to see from the film, but there's the gear selector, the long arm, and the pin that John's just removed. And if you pull it one way and push it in, you can see you engage one set of gears. And then if you pull the pin out, push it the other way, you can see the gear selector slides across and selects the other two gears that I'm pointing out now. The ratios are slightly different, so one set makes it easier and gives the engine more torque, and the other set gives it less torque but more speed. Once in gear, you can open the regulator, give the flywheel a little flick with it in forwards, and away it goes. It can be quite difficult to start it smoothly when you first get used to it, because everything's quite heavy, because you're pulling a full-size adult behind it. But once you get the hang of it, it's quite controllable. You'll see me now with my right hand take it off the steering wheel and operate the water pump, which is essentially a bypass pump. We'll have a proper look at it in a minute, but I'm shutting it here, and as I shut it, you can hear that there's a grinding noise in the background, and that's the water pump lifting the non-return ball valves to allow water to go from the tank and into the boiler. I opened the bypass valve more or less straight away because, as you can see, we don't need any water in the boiler and the pressure's not blowing off, not at the safety valves. But it can be used as a controlling measure where you can open or shut the bypass valve to let water going into the boiler or to bypass the boiler back into the tank as a controlling measure to keep the steam pressure down and keep the water level up as you drive. The more eagle-eyed amongst you who've been paying attention will probably have spotted that I used the bypass pump there again as we went round the corner. This is a closer look. There's the water pump ram going backwards and forwards, driven from the eccentric disc and strap on the crankshaft, and that's pumping the water up from the tank, up through the pump and back down into the tank again until we close the valve, in which case it can no longer take that path. So it then takes the next path of least resistance, which is up this pipe and through this non-return valve into the boiler, which, as you can see, is now cold because it's got cold water going through it. That's a good test to touch it to find out whether it's cold or hot, as to whether it's working or not. Opened up again, and the path of least resistance becomes just round that loop and back down into the tank again, which is in its normal state of equilibrium. That's how the bypass works, and that's why you shut it to stop it bypassing and going to the boiler. This is another interesting aspect of traction engines. Not all models have these. It's a water lifter hose, but on this model it works. And on the full size, these would have been used to drop over the side of bridges into streams and rivers and ponds and lakes to pull and lift extra water out of that source for the bunker so that the traction engine never ran out of water. In this case, Finn's going to drop the end into the jug that we have here, and John will turn the steam supply on, which is this valve on the foot plate, and that pushes steam through the little venturi in the fitting itself, causes a vacuum to be pulled up this hose, which sucks the water up, and as you can see, the water level in the jug's going down. The water's going up through and into the bunker. You can see the steam, which is the excess steam from that venturi, going into the tank and coming out. And as the water goes in, you'll see the water level gradually rising up through the tank until it starts to become visible and bubbles out through the top.
Here it comes.
At which point John will turn the valve off. Traction engines also have a damper on the front of the ash pan. You can see it here. Usually you want that to be open. There it goes shut and then open again. You can see the glow of the fire in through there. The control for it's up just behind the back wheel. It just allows you to put extra air or starve the air into the fire to keep it burning hotter, or reduce the temperature of the fire if the pressure's too high. So with playtime over, it's time to dispose of the fire first. Pull the R-clip out and then the pin out from the ash pan, and there's one on the other side as well, which you'll see we go through and pull now. With the weight on it, it can be sometimes quite difficult to pull, but with a little wiggle you can just pull it, and the whole ash pan and grate and coal will drop onto the floor. And then you'll see immediately that we roll the traction engine backwards just a little bit to make sure that the coal isn't burning the rubber tyres. And then Finn will drag the ash pan and the grate out and douse the whole thing with cold water, just to be sure that we're not going to melt the rubber in anywhere, and just to stop us kneeling on any hot coals. The fire now safely out of the boiler, there's no risk of damaging the boiler any further with lack of water. So it's time to blow down the steam and water that's in there. That's the blow down valve, and it just opens with a little spanner. Now we do this with a little bit of pressure so that it blows it out of there quickly. As you boil off steam, effectively you concentrate the saltiness of the water left in the boiler more and more, because you're distilling water off out into the atmosphere. Now in this case it's a copper boiler, which is a stable surface that doesn't rust, so it's really important to get rid of that salty water so it doesn't leave a coating of limescale on that copper surface, which would reduce the lifespan of the boiler. There we go, that's that. Thanks ever so much for watching. We hope you found it interesting and informative.